Next up, we have Peter Portante with the State of PyCscope, right?
Yes.
What can you tell us?
So we released PyCscope 1.1 last year at PyCon 2012, or just before PyCon 2012. And over the year, we've just done some updates to it to fix a bunch of glaring errors and to make it a little bit more useful. So basically, the current state of it is over here. We added support for Python 3 on the slide over there. We've got the number of include statements, excuse me, symbols as assignments, and we went through and excuse me, dealt with a bunch of the majority being Python 3 stuff. A bunch of people contributed to this to go do it. So basically now what you can do is if you have a symbol name that you're looking for in a pile of code that you don't know much about, you use CScope to go do it. You generate with PyCscope the database that CScope uses behind it. So it's not a utility that does. We didn't make a utility that you're looking at. We're making a database generator for a utility that already exists, CScope. And then with CScope, what you can do is now you can find in Python. We often use strings on get attrs and has attrs, where the result of doing the get attr on the string you use and make a reference to, and you work with it. Well, if you just searched for your symbol names, you would never find it. And so here, this allows you to use a tool like CScope to find the actual use of those symbols, even though they're as strings in the whole thing. And this is really for blobs of code. And you can see examples here. We also did symbol assignments. Unfortunately, this really rolls up a lot. And so this is another example where you've got assignments, so all the assignment statements, are properly found. So looking for all the assignments to the symbol sock as you go down. And, in CScope, normally with C code, the assignments are found by regular expressions, whereas here we're finding them by the concrete syntax tree usage as it goes. So we're a lot more accurate to find all the different versions of sock, and we can do stuff like here where your assignments to x comma z is being assigned as opposed to just one as well. So this is you're assigning a tuple that's an attribute of y, or 1 or 2 to x, y, x, and z. So here you can, when you do a search by assignment, you can find the complex ones that Python offers as well. And then we went into, this is just for, if people are really interested, it's not that complex in terms of what you're dealing with, other than the fact that the visualization of the tree is complex. So this is a simple abstract concrete syntax tree for this little bit of Python code. This is what the whole tree ends up looking like. And so this is the full state machine that it transitioned through in order to just to parse these 4 lines with 2 new lines to go do that. So it seems a lot more complicated, but all it is just looking for token names and import names and just in the right space to go through the sequence. And what we did to make we had some problems with symbol assignments. They weren't working right. Oops, I got the wrong one. They weren't working right, and all we had to go do at the end of it all was to just put in the right sets of pattern matching. So just as long as we look for a name, left square bracket, a subscript, and a right square bracket, etc. in here, that found the whole thing. So here you can find when A is being assigned to as an array, where C, the last attribute of 2 things, is assigned to, and where you're doing complex assignments like tuple and list assignments across. So in the list, we find C and D being referenced as assignment. And again, here's another complicated one, just because of the way the CST tree is done to find C. So that's where it's state right now. This is, by the way, those 2 examples are the Python 2.7, I believe, source code tree that it's looking through, and it is very helpful for me for code that I just don't know. So, that's the current state of it.
Fantastic. Where's the project going next?
That's a really good question. We want to get some more distribution packages out there, like having it into Fedora and Debian, whatever the package release cycles. I haven't really investigated that too deeply just yet. There's some concurrent version support. So right now, it either runs 4.2.6 or Python 2.7 or later, or Python 3 or later. I want to get it so that the utility will run for both at the same time without having to have two different installs for it, etc. So there's work on that area to just make it more convenient. Obviously, more bug fixes, and it's out there on GitHub. So if any folks that want to muck with it and play with it are there, and it's available on PyPy as well for download. So,
well, thank you very much.
You're welcome.
Yeah.